and then we can continue after 15 minutes. Topic
combustion emission control stage in diesel engine to meet Bharat Stage 6.
कनेक्ट हो गया बाकी 3 सेशन Okay, the good morning participants sitting at the centers. So we are now coming to the final day of our course, and we have with us Dr. R.S. Baj from the Department of Mechanical Engineering, National Institute of Technology, Jalandhar. So he is with us, and now he'll be talking on the topic of post-combustion emission control strategies in diesel engine to meet the Bharat 6 norms, because we all know that from 1st April 2020, the Bharat 6 norm will come into picture, and no other vehicle will be able to register, neither they'll be able to manufacture and sell it there. So it's a very important aspect. So he's with us, he'll be talking on this topic. So sir, I'll leave it to you. You can take care of this session.
Okay. Thank you very much, Dr. Benwitt. So I am thankful to, first of all, Dr. Dhami, who has given me an opportunity to interact with you. And the main purpose of my coming here is to congratulate all the countrymen for what we have done. And this first slide, which I am showing here, this is not visible now. Slide. Oh, yeah. So it is there. So this is a news item which has come in the newspaper, what our country is doing to meet Bharat Stage 6 norm. So the first thing is the India to switch towards cleanest petrol diesel from April 1, 2020. Almost all refineries were producing Bharat 6 Eurograde fuel by the end of 2019. And it's a very good news for all of us. The reason is that within a period of 3 years, our country has been able to come up to the expectations of the world. And many of the countries, they have taken much more time. And since there are many reasons that our country can do much better in many aspects, but it is only our negativity which comes into play. So this is the news. The Sanjeev Singh, he is the chairman of IOC. So he has said and this IOC, as you all know, it controls about half of the this oil production in our country. So all the refineries began producing ultra low sulfur Bharat Stage 6, and which is equivalent to European 6th grade fuel by the end of 2019. And if we just look into the emission standards, so India adopted Euro 3 equivalent to Bharat Stage 3 fuel with sulfur content of 350 ppm. So that was in 2010. And within a period of 10 years, we have brought the level to 10 ppm. So at the moment for Bharat Stage 4, we are getting 50 ppm sulfur content in diesel. And by the next 1.5 months, so we would be getting Bharat Stage 6 diesel as well as petrol, and the ppm level is 10. Now this is, if you see the change, it has come from 350 ppm to 10 ppm. So that's a drastic reduction of sulfur content in the fuel. So, and this was not possible without the efforts of the government. And one thing which our country has done, it has taken a very strategic decision to forego the Bharat Stage 5 norm and straight away jump from 4 to 6. So otherwise, it could have taken much more time than it has taken now. So we have achieved the goal, and this with this 10 ppm, this fuel will be equivalent to the CNG. So at the moment, as we all know, that the CNG fuel is much more cleaner than the other fuels, the gasoline or diesel, which is available to us. So that is the first thing. And another important aspect is the sulfur reduction will reduce particulate matter emissions even in use older generation diesel vehicles. Now, if you put a clean fuel into an older generation vehicle which is not compliant, and as you all know, from this year only 2020, we would be getting BS6 compliant vehicles, and most of the vehicles which we apply on roads, they will not be BS6 compliant, but most of those will be BS4 compliant. So if you put in this quality of fuel into that, so it will also reduce the emissions from the ongoing in-use vehicles which are not Bharat Stage 6 compliant. The new fuel will result in a reduction in NOx vehicles by 25% in petrol cars and 70% in diesel cars. So if we see the fuel upgradation policy, so our country started adopting it from 1990 onwards. So, and in 2000, our country started using the unleaded gasoline fuel. Now, the Bharat Stage 2000, which is equivalent to Euro 1 or BS1, so they were first introduced in April 2000, and it is within 20 years that we have come to the Bharat Stage 6 norms. So during this period, the benzene limits have been reduced to 5%, from 5% to 1%, and lead content in gasoline has also been reduced in phases. And at the same time, the research octane number, as you know, the octane number is giving the performance of the increase in the performance. So it has also been gradually increased from 88 to 91. So basically, more the octane number, more is the performance of the vehicle. So this is all about that, about this news. Now, the another thing which I have come and I want to share is, so I have already written a chapter on this aspect, which is available in this book. So if I'll just give you this is chapter 6, which describes everything what I want to share with you. So today's our discussion would be there on this chapter, which is already published, and this is the copy of the book. And the outline of today's interaction is, first we'll talk about the emissions from diesel vehicles, and which is the main cause of concern for the pollution related deaths worldwide, its impact, and the skipping of this the policy of government, that how they skipped Bharat Stage 5 norm and straight away they moved on to Bharat Stage 6 norms, because of which there is a reduction of particulate matter and NOx by 80 or and 50%. Then we'll also talk about the exhaust control technologies to reduce NOx and PM levels, the existing strategies to combat this PM and NOx level, which are not sufficient in nature, and that is why we have to see how can we be able to achieve this. The next, the interaction would provide an insight and suggest the ways and means to achieve Bharat Stage 6 emission standards by Government of India. So in the meantime, it will be better if we can interact. If some of you are already aware of this, so I'll start with why my today's interaction is focusing on diesel engine. So as I know, everybody understands this diesel engine, SI engine. So everybody is conversant. Okay. Now, if we compare diesel engine with petrol engine, the diesel engine is more efficient than petrol engine. Now, the reason, now if you see theoretically, for the same compression ratio, the spark ignition engine has a higher efficiency, fuel efficiency, but in diesel engine, there is a limited knock, whereas we experience knock in case of SI engine. And the diesel engine can operate at a higher compression ratio, and because of that reason, it is more efficient. And in SI engines, there is a throttling loss, whereas in case of diesel engine, it does not go through the throttling process. Straightway fuel is injected into the combustion chamber in the presence of air. Now, another thing is the diesel engine works at a higher value of gamma, that is specific heat. And because we are not interfering with the quality of fuel, straightaway diesel is injected, so gamma value is high. Whereas in case of SI engine, we mix air and fuel, and the resultant gamma value decreases from 1.4. So for air, it is 1.4 maximum. So that way, the two things, one is, I would always say the compression ratio is a parameter of engine design, whereas gamma is a parameter of fuel. So we have one, an engine, another is a fuel. Both of them combine together to give us the mechanical output. So, and both of them has to be raised to that standard. So the problem was that during the initial years, there was a lot of tussle between the oil companies and the engine companies. The oil companies would always say that we have the best quality of fuel, and the engine companies would say that we have the best quality of engine. But none of them were taking responsibility of coming up to the standard. But now both the engine compliance has also been raised to the Bharat Stage 6 norms, as well as the fuel standard, which is to be put inside the combustion chamber, that quality of fuel has also been raised. And that is why we are getting the resultant improvement. Now, another analogy which I want to give it to you is how we should see towards the emission standards. The analogy is, if we see the limits of emission standards for various pollutants, say for example CO, HC and NOx, on the x-axis and y-axis to the size of a postcard in the beginning, and today the limits have been reduced to the size of a postage stamp. Do you understand what I mean to say? So that is the reduction. So if I compare, this is the limits, and it has come to this corner only. And that is why, and this limit standard, which has been drastically reduced, could not be achieved without the total involvement of all the parameters in an engine and fuel. So the another example of diesel engine quality is that we can operate it at low RPM. So whereas the SI engine has to operate at slightly more RPM than a diesel engine, turbocharging can be done in diesel engine, whereas we do supercharging in case of SI engine. So at the moment, if we see the large diesel engines, they can give efficiency up to 55%. So whereas the ideal limit is around 98%. So that means still a lot of scope is left for improvement to move towards the ideal efficiency. So that means key work will keep on going. So these are some of the characteristics of the comparison between a diesel engine and a spark ignition engine. So it has got a better fuel economy, and we can operate diesel engine in lean condition. Now, all those who may not be knowing what is a lean condition, means more air than fuel. So as far as the hydrocarbon fuels are concerned, the ratio between air and fuel is 14.7 is to 1. Or maybe you can say roughly it is 15 is to 1. So that means you need 15 times more air than the supply of equivalent fuel. So say for example, your vehicle has to consume 1 liter of fuel, so it will need 15 liter of air for stoichiometric combustion. But for to power this engine in lean condition, we have to supply more air. So this diesel engine has a capacity or capability to work under lean conditions. Then higher compression ratio we have already talked about. Turbocharging we have already talked about. So the only disadvantage of diesel engine as compared to SI engine is the problem with the emission. So as far as the performance is concerned, it is giving better performance, and emission is worse than the SI engine. So the first thing is NOx. It produces more NOx as well as more particulate matter. Now, these are some of the disadvantages associated with the diesel engine. The first thing is it has got cold starting trouble. So everybody knows this. And all those, when we were students of BTech, we used to find the truck drivers or bus drivers on cold winter seasons that they would heat the fuel tank while parking, so that because at that time the efficient glow plugs were not there. The heater into the combustion chambers, they were not of that standard which we find today. So that is the cold starting problem, so which is very much there in our country in the month of November, December, January, or to the places of higher altitude. And that too, you can see most of the time the vehicles, the military vehicles, they were facing this kind of problem under high altitude. Another, the noise associated with diesel vehicles. Now, before, I would say 10 years, if somebody starts a diesel vehicle, immediately you would be able to know that the diesel vehicle has started. So it was audible from a great distance. Whereas the vehicles which are being manufactured today, you would not be able to make out from the audible noise whether it's a diesel vehicle or a spark ignition vehicle or a petrol engine. So you, all of you may agree with me on this aspect. So nowadays it is very difficult to distinguish through the noise or the sound level whether you are sitting or you are riding a diesel vehicle or a petrol vehicle. So another is the slower combustion. The another aspect is lower power to weight ratio. That means the total weight of the vehicle which is being fitted with diesel engine is more than the resultant SI engine. And there are too many components in diesel engine as compared to SI engine. And the much more complicated is your fuel injection system, so which is the heart of a diesel engine. And as discussed earlier, so the NOx and particulate matter. So this is the market penetration. The diesel driving fuel economy, this is 30% better than SI engine. So this comes 5% from the fuel energy volume, 15% that we have been able to eliminate the throttling loss associated with the SI engine, and 10% from the thermodynamics, that is friction, heat transfer, higher compression ratio, and higher specific heat ratio. So when we see heavy duty vehicles, you would find the application of diesel engine. You would seldom or very rarely find a very heavy duty vehicle fitted with an SI engine. In the military application, where a large weight is associated either to carry or to transport the troops, the diesel engine is there. So it's a significant market all over the world. When you see the last small passenger car market fraction in US and Japan. So in these countries, there is, in the passenger car segment, the diesel engines are very less. And as per my knowledge, many of the countries, of the developed countries, they do not have passenger car running on diesel. So they are mostly run on petrol. Now, as the topic of the day, I have focused on diesel engine. Why? There are some aspects whereby, without putting in much resources or money, we can resolve the issue of emission. The first thing is, for a country like ours, we should not have allowed diesel engine vehicles to be used in passenger cars. So that is the biggest tragedy of our country. If we have a petrol engine driven vehicle, the problem associated with this is very less and it gives a very clean emission. But then why the manufacturers have gone in for this? So can you share the reason for this?
So one of the reason is the cost of SI engine is more than diesel engine.
No. Who says?
Oh, sorry, sir.
It is the other way around. So now I'll come to that during the chapter I have written This is basically the content of the chapter. So the world wide scenario of emission norms. So let me also switch over to side by side. Now this is the chapter which I have written along with my PhD students, Dr. Rajan Kumar and Dr. Gurkamal Nayan Singh. So last year it was published in this book which I have shared with you. Now I'll come to, first of all, the reason behind the diesel engine. Now, if we read, India, as we all know, is an agrarian country. That means mostly more than 70% we depend on agriculture. And because of that reason, subsidy is being provided to the diesel, because most of the implements which are required in the agriculture sector, they come under heavy duty vehicle, heavy duty engines, and diesel engine is there. So that subsidy is provided. And because of that subsidy, the cost today, if you see the visit, so there is almost 10 to 15 rupees differential between the cost of petrol and the cost of diesel. And the subsidy was provided to for the agriculture, but the engine manufacturing companies, the automotive companies, had made use of that, and they have come up with smaller engines and put those passenger car segment into diesel. So because of that reason, the passenger car segments are here in our country. Whereas if you visit any other country outside, you would find the price differential is very, very minimum, not to the tune of even 1 or 2 rupees. Because when you go for the oil refineries, crude oil processing, so it is, you get all the ingredients, you will get some amount of petrol, some amount of diesel. So cost associated similarly, the production of petrol as well as diesel. So subsidy is being given to diesel and the cost is claimed from the petrol vehicles. So this is luring the automotive manufacturers as well as the customer. So as a customer, I will always go for a cheaper fuel. And as we have read earlier during my interaction, so diesel vehicles are more efficient. So then why people will not switch over? So as I told you, without investing, if instead of, or maybe simultaneously, if we can get rid of this, if the country decide be okay, no more vehicles in passenger segment cars on diesel, our problem will get reduced more than 70-80%. So we will have vehicles which are working on Bharat Stage 6 standards on petrol, and as such, petrol-driven vehicles produce minimal amount of emission, and which is the case with the other countries. Another is that cold starting trouble. So we would not have any cold starting trouble also. But we can only discuss here, and we are not there to enforce, but only through these interaction, I think I can make aware people about this. So that is why I have written during the introduction about this. Now, the worldwide scenario of emission norms. Now, G20 nations account for 90% of worldwide vehicles says, and 17 out of the 20 nations are obeying the European regulatory pathway to control the vehicle emissions. Now, if you say the Europe has adopted the emission standard as early as 1970, so that means it is almost 50 years, whereas we started adopting this from the year 2000 onwards. So, and over a period of time, it has come from Euro 1 or Bharat Stage 1 to Bharat Stage 6. So, let me skip the history of European standards. And at the end, I'll give you this PDF and you can read at your places also. So, let us see the scenario which is prevailing in our country. Now, implementation of emission standards in our country. The first stage of emission norms implemented in 1991 for petrol engine and in 1992 for diesel engine. In 2000, India first adopted Bharat Stage 1, and these were introduced in both the commercial vehicles as well as the passenger vehicles. Now, I will keep on referring to BS standard or European, these are almost equivalent standards. So there is not much difference in both these things. So in 2003, the auto fuel policy recommended the roadmap for fuel standard emissions. And from April 2010, Bharat Stage 4 emission norms were executed in 13 major cities. And later on, they were expanded to many other by 2014. And the target, and this is one of the, I would say, our country's pioneer work in sticking to the scheduled event. So otherwise, in many of the works which we do not stick to the schedule. We are always behind the schedule. So this is first time for this work our country is marching towards this as per the schedule, or I would say before the schedule. So already in many of the places, it has already, the Bharat Stage 6 compliant fuel has already started penetrating into the market. So since India started a formal emission standard in 1991, a gap in the execution of Bharat Stage emission norms is compared. We can notice this gap, but this gap has assisted in the technologies to mature, which helped the Indian auto sector to achieve the emission norms at a reasonable cost for the Indian customer. Now, by switching over to emission standard by 20 years later, I think we have gained that we have learned from the countries which we have already started adopting this norm. So the changes which were expected both on the refinery sector, so as well as on the engine sector, so that experience we have taken from them. So otherwise, a huge amount of resources have to be spent our own country in order to meet this. So we started late, but we made up to the mark. So throughout the world, everybody is now Bharat Stage or Euro 6 compliant. So I think in a way we are gainer. So that is what I have written here. Now you are all aware about OBD, that is onboard diagnostic device. Now today the vehicle which is being manufactured or the engine which is there is not a mechanical component. More than 40% is computer controlled. There is an ECU fitted on board the vehicle, and all the mechanical adjustments have been eliminated through the use of computers, sensors, and actuators. And the job is being done, and the name of the device is OBD, onboard diagnostics. Now, there is a series of this thing. There is OBD1, which came into effect 1991. So you all must be aware about the CARB, that is California Air Resources Board. So California, which is a state in US, was the first to implement the emission norms as early as 1964 or 5. So how it came, this board, how this board became, that one day what they experienced, that all of the sky is totally covered with uh, dark clouds. So they investigated the problem, and initially people thought that this fog has come, or this smog has come from the chimneys of power plants. But later on, they researched and they found out the 65% contribution to the emission was from the automotive transport sector, and only 30 to 35 from the industry sector. And they immediately formed a board, and from there they started fitting vehicles with an OBD device. And the OBD device at that time known as OBD1, so it was nothing but to monitor the emission control components, whether the emission control components are functioning properly or not. So before that, there was no other mechanism to check the emission control device. But today, then we have this OBD2, which has got, so it is fitted onto the vehicle since 1994, 95 or 96, and all 1997 and newer diesel passenger vehicles and trucks were required to meet OBD2 requirements. Now, the first we had OBD1 was the emission. Now, in OBD2, along with the emission, a user-friendly system was fitted on, and it was required to give a signal for its malfunctioning. Now, most of us are driving vehicles nowadays, and when you start the engine, you see onto the dashboard there is a check sign which comes, which glows. So at that time, this is similar to what a computer does when you initially press the start. It boots, and by booting, we understand it checks all the components and software and hardware be okay. Now I'm ready to use. So similarly, in vehicle which are being fitted nowadays, they first check everything, and they gives you a thumbs up sign, be okay, everything is okay, you go ahead. So otherwise, that sign will not go off. So that means if something is wrong with the engine system. And today, earlier you would take it to the mechanic and he would start doing something there. Nowadays, all the workshops, all the mechanics, they have scanner. So it's a software which they carry into their laptop. There is a port under the dashboard. You put in your dashboard, this lead into that, and you get all the signal and data in the form of software, and it will tell you, okay, this is the code and this is the component which needs replacement or which is malfunctioning. So they either replace it, because today I'll say most of the time we have come to the age where replacement is done, repair is not there. So the mechanical component, I would always prefer, we had the choice, and a good mechanic is always the one who could repair, not replace. But today, whether it is your computers, whether it is your mobile, whether it is your vehicle, anything, so the moment it gives a malfunctioning, the technician would come and say, sir, this component or this motherboard or this needs to be replaced. That's all. Now, for a country like us, I think replacement should not be there. I always consider this as wastage of resources. And we have sufficient manpower available. So this was for the countries where the labor cost is high and the manpower is not available. And if we go for replacement kind of thing, so our manpower will remain idle. So the one way to use the manpower available in our country to repair the replaced components, whether it is computers, whether it is mobiles, or whether it is automobiles. So that is one of the losses associated with the digital revolution, the electrical transfer, which has overcome the mechanical components. So I think the role of OBD is clear now. And nowadays, we have progressed into, you would say, the OBD 2 and OBD 3. The OBD 3 or 2.5 or the higher version, the hierarchy as we progressing, is a one step ahead. That earlier you need to bring in your vehicle to the service station, and from the OBD you put a scanning device and it gives you the information regarding the malfunctioning. The OBD3 compliant vehicle would have the facility to display on board the malfunction. That means the scanner is already installed into this. Now, you would appreciate, initially, we had printers and we had scanners. And today, if you see, it's a 3-in-1 device. We have printer, scanner, or maybe the photocopier fitted onto a single unit. So that means the evolution of OBD is to combine first to diagnose or detect, then to give us an information which component is malfunctioning, and third, to give us a reminder on board, yes, this is what is happening. And this is the same case is true with your mobiles and your laptops, that they gives us an advance warning. Okay, memory is full. You delete some data. Okay, this particular software or this particular file is not working. So similar is the case, and I think so. For the brief period I sat with Dr. Bennett, he also said something about the hacking. I think he was talking about hacking. So another disadvantage with these electronically controlled devices is the problem of hacking. And for that matter, the security of such a system is of great importance to us. So the next revolution, I think, which would come or which is already there, or next biggest problem all over the world, like one of the problems we already faced was Y2K problem. So you are already aware about this Y2K problem? So when we switched over from 1999 to 2000. So the similarly, another problem that we have mobiles, everybody is carrying, we have laptops, we have electronic fitted gadgets like automotives, refrigerators, ACs, everything, air conditioners, they are all electronic controlled, Wi-Fi controlled, Wi-Fi enabled, even your the door lock system. So the hacking, we have to safeguard ourselves. So a great amount of work is required for the safety. So many a times we heard ATMs also. So ATM fraud again. So it is similar to here. So that I think will be resolved by OBD3 or OBD4, the subsequent devices which will come. So they will have these features of, and one such vehicles I think is already in the market also. So it has internet compatibility. So everything, you can put a guard also. So somebody rides that vehicle, so it gives you information onto your laptop. So it is connected to your laptop also. Now the technology upgradation from conforming to Bharat Stage 4 and Bharat Stage 6. The advantage associated, we have already talked, that it gives us limited amount of emission as compared to the previous vehicles. But this is available to us at a cost. Each vehicle which is Bharat Stage 6 compliant would cost at least more than 10, 15, 20% of the cost of the vehicle. So that cost everybody has to bear because it is fitted with many number of components, which adds number one, cost of the vehicle, number two, the weight of the vehicle. If you add more devices onto the vehicle, so power to weight ratio will decrease. And because of those more number of components, more number of sensors, more number of actuators, and why it took 3 years, 4 years, 5 years, 6 years from moving from Bharat 6, 4 to 6 is that you need to upgrade the software. Now, everything today, whether it is fuel injection, whether it is the performance of the vehicle, fuel economy, your OBD devices, they all are software driven. So, huge amount of time, data management was involved in preparing the revised upgraded software. So that is why it took so many years. The only thing is, even though we are spending as a consumer 15-20% extra cost, but we hope to save many lives. So many lives are lost because of inhaling the harmful emission present in the environment due to the passenger car segment. So that is the relief to us. Okay, let us spend something more, but somebody should not die because of this. So that is what we have written. This cost would be recompensed by the drop in decreased diseases due to air pollution, which are severe threat to human healthiness in India. Now, there is a famous saying, GIGO. GIGO in computer system known as garbage in, garbage out. That means if you feed wrong data to the computer, it will give you wrong answer. So that is known as GIGO. Now, similarly, if we fill in our vehicles with poor quality fuel, we will get poor performance and poor emission. That means more emission, more pollutants. So the fuel quality has to be upgraded along with upgrading the engine or the passenger vehicles, automobiles. So today, and that is why so much amount has been spent to increase. So the quality of fuel affects the quantity and type of exhaust emission from the vehicle. So it is the quantity as well as the quality which is being affected with the fuel. It directly and indirectly affects the quality of air and the amount of greenhouse gas in the environment. Improving fuel standard would facilitate vehicles and their emission control system to work effectively and assist in the adoption of advanced engine and exhaust emission control technologies. Now, one aspect we have seen here is that we have to improve the quality of fuel. Another is, if we have fitted the emission control strategy, devices and we feed them poor quality fuel, they will start give malfunction. So a Bharat Stage 6 compliant vehicle, if it is fed with Bharat Stage 1, 2, 3 or 4 quality fuel, the emission control system would fail. So please, so that is why our country or the oil companies cannot sell two qualities of fuel. Be theek hai, Bharat Stage is also being sold. At the same time, Bharat Stage 6 is being sold. No. So in a unleaded fuel vehicle, if you put in leaded fuel, so don't get carried away by the word unleaded. Unleaded still has got some amount of lead, but the ppm level is very low. So the safety of the emission control devices also depend, their functioning also depends upon the quality of fuel. Okay? Yeah. So we need to be aware about this. During combustion, sulfur in diesel fuel is converted into PM emissions via sulfuric acid and sulfur dioxide emissions that led to subordinate particular development in the atmosphere. These chemicals can also cause acid rain. So sulfur also obstructs the proper working of after treatment system, designed to low down the tailpipe emissions and corrode engine types. So that is why it has been reduced from 300 ppm to 50 ppm to 10 ppm. So 10 ppm is nothing but almost nil. So whatever the vehicles will come, so that will have least amount of. So this is the comparison of Bharat Stage 6 and Bharat Stage 4 fuel quality. Now the combustion, that is the improved NOx advanced EGR system. Now in Bharat Stage 6, you will have OBD 2 or higher version. Then we have after treatment devices like SCR, DOC and DPF, for which I'll talk with you in detail after the break. So let us see a figure here. In India, from 1999 to 2017, the sulfur content has been reduced in diesel fuel from 10,000 ppm to 50 ppm, whereas 10 ppm sulfur content in diesel is planned to be supplied.
Let me have a tea break for 15 minutes.
So, okay. So let me finish this. So when we come back after tea, we'll talk about advanced engine combustion strategies. So thank you for your patient hearing.
Yes.
Thank you.
हाँ जी। एक यहाँ पानी रखवा देंगे।
हाँ आपके नैन वो भी चाहिए
वो चले गए।
चले गए
हाँ
अरे तो चाय वाय तो पिलानी थी मैं फिर थोड़ा
कोई बात नहीं, कोई बात नहीं, कोई बात नहीं। वो वहाँ एटलांटा चले गए। मेरे को आप वहाँ टाइम स्पेंड कर दो। तो लास्ट टाइम जब मैं आया था तो वो जुड़े हुए लोग बड़ा इंटरेक्टिव सेशन चल रहा था। इस टाइम इतना इंटरेक्टिव नहीं है। I don't know.
force material वही एक
सुनो वही नोट कर लेते हैं आपको बताना हाँ जी सुमील बता दो
मोहन
MOHN
L
यस सर
not Peli PEL
ठीक है सर
हाँ
सर एक बार
@gmail.com
I think जैसे वो पूरा करेक्ट हुआ है
तो भी available materials है
ठीक है
नीचे वाला इसमें
हेल्प लेनी है तो ठीक है कोई दिक्कत नहीं
काश नहीं आना
सर्टिफिकेट इसमें तो चलेगा अभी
चलेगा सर्टिफिकेट लेकर आओ
ओके
लेक्चर बैठो साथी से करें हाँ हाँ हो जाएगा सर हो गया थोड़ा सा कलर करना पड़ेगा आपका 50% बातें दिखाएंगे मुझे कुछ मतलब हाँ ये स्टार्ट करवा दो और कोई क्वेश्चन क्वेरी है सेंटर्स की तो पूछो और सर से इंटरेक्ट करवा दो उनको सेंटर वाइज
This is Punjabi University.
Yeah, okay.
So mic is there only, so we have to.
हाँ यस
Hello. Hello.
पूछो आप बोलो
At Punjabi University, sir, is there any query? And please call your participants. We are about to resume the session.
Hello, ma'am. Good morning. Good morning, sir.
Haji, good morning.
Sir, no query, sir, till now.
Okay.
Okay, thank you, sir.
Okay. How many participants are there?
Around 13, sir.
1, 3.
Yes.
So, okay.
So after the session, immediately after this, we'll have the valediction also. So please call your participants so that they can interact with sir.
Right, ma'am. Right, ma'am.
Okay, sir. And Narsiraopeta Engineering College. Are we audible at Narsarao Peta Engineering College? So please switch on your mic from the screen, and if there is any query, please ask. Hello.
Hello, ma'am.
Good morning, sir.
Hello, ma'am. I'm audible to you, ma'am.
Yes, sir. You're audible, sir.
Presently, I am no queries, ma'am.
Okay, sir.
So, are you following it or just simply saying there's no query at all? So that means
Following, sir. Following, sir.
okay. Right.
Okay, thank you, sir. And the another center is Panimalar Institute, Chennai. At Chennai center, is there any query? Please switch on your mic from the screen of the desktop. Is the coordinator there? Sir, is there any query, sir? I don't think there are any questions.
So I think they are not able to.
They're not. Somebody has come to that side.
Mhm.
Actually, they need to switch on the mic from their end,
Okay.
and then the mic is put off. So we can start the session.
First, let's have interaction with them, and then we can switch on. So once we are interacting here, that is also.
Yes, sir. From here, everything is being transmitted.
Okay.
It is just when we'll present them, they'll be like listed in the icons there on that screen.
Okay. So.
This was the
No, this is not mine.
Okay.
This one that is-
Yes, sir. No.
So, welcome back, friends. So, I hope you had a night's warm tea. So, let us have a small interactive section for 5 to 10 minutes. So, and revise whatever we have said so far. So, I want that each one of you should at least say something, either as a query or whatever you have understood. So, whatever we have done so far. So,
SCR technology.
yeah.
And is it possible to two-wheeler engine?
Use.
SCR technology uses only in diesel engine or petrol engine?
The first thing is I have not talked about SCR so far. So during this session, I'll come to that, and this query we'll take up after that. So let me first introduce what is SCR. And next, so we can.
We can reduce emission by changing the fuel quality, as well as by changing the modification in engine.
Now, one thing, let me make it clear to you. Today's engines, which are fitted onto the automobiles, they cannot be modified as per your choice. Now, since I see how many years you have been using the vehicle?
15 years.
15 years. 15 years ago, when you had a vehicle, I think at that time, when the electronic or OBD device was not fitted, the customer, the driver, the mechanic has that freedom of making some changes either to the carburetor or to the exhaust or to the fuel. But today, like it is something like your laptop, you cannot play with the operating system. Similarly, in mobile phones, you cannot operate with the operating system. So we can always go through the application. So that manipulation is not possible into the vehicle. A slightest amount of modification on engine, if you do, so the check sign will be there onto the dashboard. And that is the beauty of OBD device. Customer has no access. Only the admin can do it. So admin is the OEM, original equipment manufacturer. So at the company end, it can be done. So they also keep on revising their software updation. So they call you, or when you go for the servicing, they update your software, something like that. Next. Next. At least one query.
Sir, we have
No query?
so I have asked you.
Okay. From the last.
Sir, OBD device just like a part of AI, artificial intelligence. One part, small part.
Artificial intelligence is more like a software. It's more a data management. So in OBD, you have hardware as well as software.
OBD device, both are required, hardware and software.
Yeah.
There is a one chip just like a washing machine. You can just give some input.
Yeah.
Washing machine there's a facility.
Yeah.
But in this facility is through the sensors the inputs are given, and they decide the according to formula and chips. So just like a small part of artificial intelligence, small part, not entire. We can say
it's not a chip, it's a computer in itself.
Yes, sir.
It's a small computer in itself, which is fitted onboard
Like
dedicated computer. Yeah, microcontroller. Yeah. Yes. Next.
Like sir, another good example that you have given, like Vigo, like garbage in and garbage out.
Yeah.
So to build the standards of the BS6 norms, so the engine manufacturer also raise their standards, as well as at the same time that the that oil industries also raise the quality of the oil, so that it is a like collaborative work, so we can get into, so that we can achieve the BS6 norm.
Yeah. So I think earlier in our country, basically a blame game was played. So the oil manufacturing companies always were finding fault with the engine manufacturing companies, and the engine manufacturing companies were always finding fault with the oil supplying companies. So that way we keep on lingering on, and the things were not achieved. So this time only, I think both of them have combined together, and there could be, I say, some global pressure also. And at the same time, the public is now also aware about all these things. So more public awareness is there through social media. So because of which a pressure is already on both the sides. So today you cannot befool the people all the time on all the issues. So you have to come out with some solution, and this is the very good sign and good news for our country as well as citizens, so that our country is doing a good job collaborating. So otherwise, to work in a team by Indians is very, very rare thing. So individually, we all are better than many of the individuals. But as a group, as a team, we are even not equivalent to a single person outside. Yes. Anybody else?
So what are the components which we are using in OBD device?
Component is a microprocessor, a computer. So along with sensors. So there are more than 13, 14 types of sensor fitted into the exhaust, into your throttle control system, temperature, coolant management, fuel injection, manifolded. Yeah. So all these sensors are there, actuators are there. So a reading is taken from all these devices, and according to the programming, mapping is being done, and then fuel supply or other functions are being carried out. So should we go ahead now? So let us now move on to the advanced engine combustion strategies available. Now, the advanced engine combustion technologies basically deals with the in-cylinder, what is actually happening inside the combustion chamber. Now, in both the cases, whether it is SI engine or a diesel engine, combustion is basically happening inside the combustion chamber. And I always give an analogy to this. The concept of engine, which has come to the human beings, I always say it has come from the human beings itself. So, whatever is food to the human being, it is fuel to the engine. And whatever is there, the food we eat, accordingly we give performance. Now, similarly, whatever fuel you supply to the engine and whatever happens inside the combustion chamber, accordingly an output, performance or emission is being reflected by that. So a lot of study is being done what is happening inside the combustion chamber. In order to study the in-cylinder combustion, very, very sophisticated devices are required. So maybe we in our country, we may have only 2-3 labs which are equipped with that. And mostly whatever we do is outside that. And most of the research which is being carried out here, and during our interaction, some of you were talking about the PhD or research work. It is only we are measuring the performance. We are measuring the emission parameters. We are measuring the performance, that is brake thermal efficiency, heat release, something like that. By either mixing the fuel, that's all. And nothing is being carried out into the engine section. And a very high level of, I would say, knowledge, equipment, laboratory is required to understand the anatomy of an engine. So basically, here what we do, mostly the engines are being designed outside. We are procuring them, using them, and getting the work done. As is the case with most of the mobiles, most of the computers. So we are only importing this and we are making use as a applicant. So the first thing I think I have already talked about is the low temperature combustion strategy. Now, if we see NOx is a parameter which is associated with temperature. Now, the NOx, amount of NOx emitted as a pollutant from the engine keeps on increasing in an exponential way as the temperature increases. Now, say for example, at 1000 degree centigrade combustion temperature, X amount of NOx is released, and at 1500, it may be X plus X plus X plus X. It will not be 1.5 times, but it will be many, many times more. So that is the behavior of NOx. And as we all know, air has got two components. Now 21% and 79%. 79% is your nitrogen. Now nitrogen at normal temperature do not participate into the combustion chamber reaction, because we are also inhaling nitrogen, but it is not participating because the temperature inside our stomach is maybe 31, 32, 34, 56 degrees. But engine also inhales air, same oxygen and same NOx, but it produces NOx. because it is working at a temperature of around 2000 degrees centigrade. So that is the biggest. So for that matter, the maximum amount of NOx is being produced by gas turbines or gas engines, which are being used in aircraft. More than 90-95% NOx is being produced there. So that is why we have to be very, very cautious in dealing with this. So if we are able to decrease the combustion chamber temperature somewhat lower than what it used to be, so definitely we will be able to control NOx emission. So low temperature emission to low temperature combustion, so NOx can be minimized. Yes. So the LTC, that is low temperature combustion, offers a number of advantages over conventional combustion. The fuel air mixture and combustion properties permit the engine to be more efficient than conventional engine. The energy losses in the engine is less over the cylinder walls to the atmosphere due to lower. So one, you reduce the NOx. Another, you reduce the energy loss which is there through the walls of the combustion chamber. So both way it is beneficial. So with a low temperature combustion, we may be achieve ultra low engine exhaust emissions, which could significantly decrease the cost and after treatment devices or which is penalties for fuel economy. Now, if we have a high temperature combustion, the exhaust emission after treatment devices will have to be more stronger. So when we have low temperature combustion devices, a low temperature control after treatment device can be used for the emission control. Now, clean diesel combustion strategy. Now, in this, more air or lean, this is similar to lean combustion technology. That means more amount of air is being inducted into the combustion chamber as required as per the stoichiometric air fuel mixture conditions. So we induct purposely more air for leaner combustion. So that leaner combustion can be treated as cleaner combustion. Lean combustion is a clean combustion. So another analogy I used to give into my classroom is what we do with the yoga, what we do with sports, with our body. The only thing which we do with yoga or sports is that we inhale more amount of air. We fill in our lungs, nothing else. You do any physical activity, your inhaling rate increases. And that means it is better for the food which is there in your stomach. So fuel or food is nothing but carbohydrates. So in order for combustion, you need sufficient amount of air. So human beings always remain deficient of air. You start inhaling more air, you give more air to the engine, it will produce lean combustion, and you will get lesser number of pollutants and better performance. So the same analogy works here. And this has been possible with the use of computer control, high pressure fuel injection, multi-pulse fuel injection system, so EGR. So all these things make use of clean diesel fuel technology. Now, exhaust after treatment strategies or devices. Now, exhaust emission of NOx and PM, they have been reduced to more than 80 or 90% from the previous years. And this has been done with the modification, retarded timing, cool EGR system, and high injection pressure. Now, if you see the engines, diesel engines, which were being manufactured earlier to, I would say, Bharat Stage 4 or Bharat Stage 6, they were basically working on 1000 psi injection pressure. But today, they are being used to run at 2000 psi. Now, with such a high pressure, what is happening? In a diesel engine, we have to atomize the fuel. That means we have to break down the fuel component into finer particles. And that is only achievable with higher pressure. With lower pressure, the molecule size is bigger, whereas with higher pressure, the molecule size is smaller. This is one thing. Another, I think, change which has come in diesel engine is the CRDI technology. I don't know whether you understand this CRDI to what an extent. Anybody who can give me an idea regarding CRDI? What is CRDI? Have you heard? Common Rail Direct Injection System?
Yes, sir.
What it is?
So we use ECU system to inject the diesel inside the cylinders.
Okay. So that becomes CRDI?
So the ECU is one of the components which is used in CRDI system.
No, that is true.
Yes, sir.
But how it does? What is common rail direct injection? Simple question.
That injection is based on once that cylinder is reaches the top dead center, so that electronic system gives the signal that again further gives the signal to the injection system that.
So that is the normal injection system. But what is meant by how it has been changed by CRD? Okay, leave that aside. I'll give you a small analogy. How many of you stay in multi-story buildings? Anybody who is staying in multi-story building? No.
Land.
Hmm?
Land less. Multi-story building.
No. Now, in multi-story buildings, there is one problem. When we use, maybe some of you might be staying in hostel also. 1, 2. The person who is residing at the top will get a lower pressure water from the person who is at the ground level. Have you heard this phenomenon or no?
Yes, sir.
The water supply system in a multi-story building, the person who are residing at the top, they keep on getting lesser water flow, lesser pressure than the person who are living at a lower level. Is it true? Yes. Now, this is what was happening in an engine earlier to CRDI engine. Now, the cylinder which was nearest to the fuel injection pump was receiving the maximum amount of fuel. The cylinder which were farther away from the fuel injection system was receiving fuel lesser than the first cylinder, if it is a 4-cylinder engine. So because of this mismatch, because cylinder size is same in all, and all the cylinders should receive the same amount of fuel. So because of differential amount of fuel, the combustion in a multi-cylinder diesel engine was not proper. And because of that reason, we were getting noise and vibration from the engine. Now, how Can I draw something here? Is there some facility by which I can? Okay. So can I draw here in the paper and show it to them? So can you give me a plain paper? Yeah, this here.
Or else we can draw on that screen.
That screen I can draw?
Take the projector out.
Let me explain. So that will be a good thing. So this is a multi-cylinder engine having 4 cylinders. Now the cylinder 1 is nearest to this. This will receive more fuel than cylinder number 2. This will receive still more fuel than 3. And this will receive more. So this will get least as compared to the first, the fuel. So this is the similar to the situation which I have explained, like in multi-story buildings. So this is the ground floor, which will receive maximum pressure. And in some of the cases, when the ground floor people would always open the country, pani upar jayega bhi nahi. Okay, so this was happening in the engines before CRDI. And now, how this problem has been resolved, this is Robert. And I think from today, you would understand the CIDI technology and never able to forget it. Now, in this configuration, each of these cylinders would receive the same amount of fuel required by them. It is not the ECU. ECU is there in first case also. But ECU here is also there. ECU is there in both the cases. But ECU supplies whatever instruction to give. So now, if you design a system like this, and this is known as your common rail. This, and this is a high pressure rail. And earlier, the conventional engines were having on low pressure fuel injection pumps. And now these are high fuel injection pumps. And because of this, today we are able to see the diesel engines or SA engines having almost similar audible noise, no vibration, no noise. So otherwise, initially, diesel engine start hua, so people would start with how engine chal pada. Is it understood now, CRDI?
Sir, if I use the high pressure injection pump in a conventional system, again then
those similar, the problem, whatever type of pump, actually you see the distance, the time required to travel the fuel. It is because of the distance. So this distance. So I have exaggerated this problem.
There will be a loss.
There will be a loss. Loss also.
Yeah.
Pressure loss. So here, this rail is pressure.
Maintain the pressure.
Same pressure. You tap it from here. The pressure will be this way. Still, I think there is. Okay. So pump does not do anything. So the only thing is, because 4 tappings have to there, so this is pressure is slightly more than the conventional system. So CIDA may 2 changes, one this rail, another is the pumping system. So it has become high pressure. And because of this reason, the entire thing has resolved. The performance has improved, the emissions have decreased. Apart from the exhaust after treatment devices which we are talking about. So आज के बाद I understand कि अब आपको CID कभी नहीं भूलेगा.
Sir, can we apply the same technology to multi-state building?
Yes. And nowadays, the multi-story buildings are designed and the water supply is done like this. अब यही हो रहा है. जो older है उसमें नहीं है, but in a newer, this is being done. So you go to 20th floor, you will find the same amount of water. You go to the ground, it is the same. उसमें भी ऐसा ही है, same. यहाँ पूरी स्क्रीन नहीं आएगी. Earlier it was there. चलो नहीं तो ठीक है. अच्छा वहाँ पर भी आ रही है, इधर भी आ रही है. चल ठीक है, कोई बात नहीं. Now, before I discuss these individual after treatment devices, let me show you the complete exhaust system, that how it has improved and what is there in the Bharat Stage 6 vehicles, 6 diesel vehicles, which will be fitted with this. And then I'll come to the now, if you refer to figure 6.6, this is the transition which has taken place, or I think which is going to take place in the vehicles which are being manufactured from April 2020, whether they are passenger vehicles or they are commercial vehicles in DC. So you have an engine which is fitted either with EGR or without EGR. Then you will have a DOC, that is diesel oxidation catalyst, then diesel particulate filter, and then SCR, and then tailpipe. So these 3 components will be there into the exhaust system of a diesel vehicle. And because of this, they were to redesign the vehicle because it has to accommodate into the limited space available with the vehicle. And secondly, all these devices are fitted with sensor. And otherwise they would not function as it is. So now going back one by one to the system, that what they do and how they work. And all of this, then recalibration of the entire software was involved. Now, oxidation catalysts in automotive were equipped maybe from 1970 onwards. We have already seen two-way, three-way catalytic reactors. So this is an image which gives you the idea regarding the engine, the EGR, that is exhaust gas recirculation, then the control unit, then the intake, and this is the cylinder head. And in the initial system, when turbocharger were fitted, now slightly I'm taking back again to the history of, I would say, evolution of diesel engine in passenger cars in India. The first vehicle, I think, which came into passenger car segment fitted onto the diesel engine was from Tata Indica. I think everybody knows this. Maybe that may be it, yeah. Now, they launched the vehicle that was without a turbocharger. Later on, after a year or so, they came up with the upgraded version. This is Tata Indica Turbo. Then they came up with another version after 2-3 years, Turbo Intercooler. Now, as far as the diesel engine is concerned, a diesel engine is a one which is fitted with a turbocharger, and in order for the better functioning of turbocharger, you need to have an intercooler. Now, first of all, why a turbocharger? Now, turbocharger is fitted onto the diesel engine because some of the diesel fuel which is there in the combustion chamber, they go out of the exhaust without participating in the combustion reaction. So that means HC emission, जिसको हम लोग बोलते हैं hydrocarbon emission. You get hydrocarbon emission into the diesel engine, and which is clearly understood by the fact if you happen to be near a diesel driven engine vehicle, you will find some smell. And from where this smell is there? Because the exhaust is also giving some amount of diesel. So that smell is being inhaled. Now, the fuel, which is unburnt hydrocarbon, it has to be reinducted into the combustion chamber. So that means the resultant unburnt hydrocarbon in the exhaust are lesser. They are reused. That is why, and this system which circulates this entire process is known as EGR, exhaust gas recirculation, of which turbocharger is a part. Turbocharger is nothing but a small turbine. So we all know what is a turbine. So turbine is a power plant which works at a very high RPM. The turbine which is fitted onto the diesel engine is rotating at more than 1 lakh RPM. and to manufacture or to fit a turbocharger into the diesel engine, again, cost will go up. So the company which were manufacturing, they deleted this component, put up the automobile into the market as a cheap product. Whereas I consider this as an essential part of the diesel engine. You would not find EGR or turbocharger into agriculture sector, diesel engines. They are without these. But if you happen to work on those, please try to fit in a turbocharger. You will get better results, especially for you. Now, when you supply EGR, the hydrocarbons, they are at a higher temperature. You need to condense them. And in order to condense, what we do? We cool. When we cool, the exhaust would condense. So, with this, more amount of fuel, exhaust can be fed. So, cooling of the exhaust is also compulsory when you fit in turbocharger. So, that is known as intercooler. So, again, that means that intercooler is also essential. So, in the first step, they avoided turbocharger. In the next step, they fitted turbocharger, then intercooler. Then it became a complete diesel engine. So nobody knew these things and these companies started paying. So that is why, again, a model, you would find turbo written behind that. You would find intercooler written behind that. Yes, it is fitted with intercooler. But to me, at the first stage, they should have launched diesel engine vehicles with all these things. And second, today what we are talking about, Bharat Stage 6, people have already implemented in the developed countries. We are only imitating. It is not a new thing. It is new thing for India, but it is not a new thing for the world. The world already knows about the entire this thing. So, hope this thing is clear to you. So that means ki diesel engine with turbocharger intercooler. So that makes a diesel engine, especially into automotive sector or transport sector. So now this is a catalytic converter. We supply HC means unburnt hydrocarbon, CO, which is a product unburnt. This is carbon monoxide, oxides of nitrogen. When it passes through a catalytic converter, we get nitrogen, water, and carbon dioxide. So is it?
Water is possible to corrosion into the silencer.
Now another important thing is, we always say it is water, but we never see it. Where does that water goes? Anybody who has seen this water? Okay, so you have not seen, but I have seen. Now you can do one experiment in the winters. When you start your engine, you would find some droplets coming out of the tailpipe. And this corrosion which he is talking is because of that water. So for that matter, you can, I think, go for some coating and it will not be there. So coating can prevent this water. But in cooler months, like the month of November, December, when you initially start your vehicle, you would find initially some droplets of water coming out from the tailpipe. But as the temperature increases, as soon as it comes in contact with the normative cell, it disappears. Now, the room in which we are sitting here also contains some amount of water into the air. But they are so minute that they are not visible to us. They are scattered. So air is always it has got oxygen, it has got nitrogen, it has got water, and it has got the pollutants also, always there. But we are not able to see them. So now you can witness this thing doing by an exercise. You start your diesel engine vehicle in the morning, cool months, and you would find it is there. So the carbon monoxide, the unburnt hydrocarbon, the carbon monoxide, when it passes through the catalyst, it reacts with them and you get oxygen, you get water, you get carbon dioxide into the exhaust. So that is the role of DOC. Now, the next component which I talked was DPF, diesel particulate filter. Again, I'll give you one analogy. What is DPF? DPF is nothing but a mask worn by the people who are living in the high polluted cities. And you must have seen the police cop wearing a mask for inhaling. So a similar filter is fitted onto the tailpipe of the exhaust of diesel engine so that it can arrest the heavier particles into that filter and leave the smaller particles. So there, like when we have a filter, it arrests which are not good for us. So similarly, it attracts, and periodically you have to clean the filter. So similar is the case here. So this exhaust which is there, it has to be cleaned periodically. Maybe the design may be such that it will be take 50,000 kilometers or 1 lakh kilometers to replace it. So since cleaning is a difficult task, you have to entirely maybe change this component altogether. Like we have air filter. So everybody knows. So air filter needs to be cleaned, or rather it has to be cleaned or it has to be replaced after maybe 5,000 or 10,000 kilometers. Similarly, we have fuel filters, and similarly now we have exhaust filter, which has also to be periodically cleaned. So otherwise it will choke the exhaust, and the whatever we are talking about pollutants, that problem will remain there. So the construction of DPF is similar to a honeycomb type of structure in which the exhaust grows from one side and it comes from the other side. It has got pressure sensor, it has got temperature sensor. Okay, so now two sensors are here which are linked to the ECU. So earlier some input was there, now two more inputs are given to this. So that the operating system needs to be recalibrated. Software needs to be upgraded. So say for example, pehle 5 or 10 inputs are there, now 2 inputs are more. So detail, I'll give you this PDF and you can read this PDF for details. Now coming to your this thing SCR, selective catalytic reduction. Now this is also a very simple thing and which has been used. Now if we see, the SCR is a procedure that uses a catalyst to change over NOx in deplete gases to nitrogen and water, which are then discharged into the air. So in order to reduce the quantity of NOx, or in order to reduce or turn NOx into nitrogen from maybe 80-90% to almost negligible 1 ppm to you need to react with some kind of catalyst, and then it will convert NOx into water and nitrogen. Now, what this catalyst is, it is nothing but the urea which is being used in the agriculture sector. And you can see the companies, how do they do? They sell the same in the name of AdBlue. They call it as AdBlue. Now today, if you find urea, you will get maybe 200, 300 for a bag of 50 kilograms. And once it's come to automobile, it will be sold 1 liter of urea costing the 50 rupees or 100 rupees. But it is nothing but a mixture of water and urea. You can make the same urea, the 30-40 grams, mix it with water, make a liquid, and inject it to the NOx. And we have experimented with my PhD student. We have constructed an ordinary exhaust, and we sprayed urea into this, and we have seen 90% reduction of NOx. Simple mechanism. Simple spray of urea into the exhaust, measuring the exhaust before inducting the urea and after inducting the urea. So 90% reduction is there. But these companies would have a sensor. Okay, the one thing is there, yes, in order to have maximum benefit or the efficiency of this SCR device, it has to be operated at some raised temperature. So that means the whatever sensor is fitted there, initially during the cold conditions, when the engine start, the urea dosing does not start. It is only after sensing the temperature, when it reaches around 400-500 degrees centigrade, the dosing of urea is done. That means the injector, urea injected nozzle, starts dosing the, and then it is also fitted to the exhaust also. One sensor is another there, which gives you the okay, it is now going, nitrogen is going outside, NOx is not going. So feedback mechanism is there. So dosing of urea, quantity of urea, temperature sensor, this again input has to be sent to the ECU. So that means you require the upgradation, then you require this fitment of these sensor and actuators into the system. So all these things combined together took 3-4 years time to build this. And the resultant is that now we would be able to inhale some of. So that is why I am not going on for detail. I have given you the crux. So here I have also written. So diverse forerunners of ammonia can be utilized. However, for vehicles, the most well-known alternative solution of urea and water, for example, AdBlue. So one company, it is selling urea and mixture of water in the name of AdBlue. So you can mix, I think, 32% mixture, and it will work good for this. So that is it. Now you come to your question. What you wanted to ask about SCR? You wanted to ask something at that time. I stopped you.
Something is possible to four-wheeler. It's big equipment. SCR is catalyst unit is very big.
Okay.
As it reduces size and it's comfortable to four-wheeler. How to change it? Now it is possible to heavy vehicles only. It will reduce to four-wheeler. How to change it?
Passenger car segment. The size can always be reduced.
The earlier class size is only used in heavy vehicles.
No. Initially, they were used in heavy vehicles, trucks and buses. But nowadays, the high-end vehicles, they are making use of this device. So you can always reduce the size. Small pump is needed, small this thing is needed. But the only thing is, now you see the configuration of a bigger vehicle. Now the vehicle, say for example, let us talk about the engine of this thing, diesel train. So this engine is producing 5,000 HP or 6,500 horsepower. So it's a very, very big engine, which I think is equivalent to hundreds of smaller engines. So the bigger the size of the engine, larger would be the amount of exhaust. And a vehicle which is having 1000 cc, 1500 cc engine would be producing a very small amount of exhaust emission, which may not be, I think, even if we add this thing, the resultant benefit derived would not be there. Whereas if we target bigger vehicles like trucks or buses in transport segment, so it will cater, one vehicle would be equivalent to the 100 small passenger cars. So that is why initially they are implemented there. So this emission, I think during our tea break, I was discussing, more the number of vehicles, more is the exhaust emission. Now again, in US, they are having 2 vehicles per person. So if the population of US is maybe 30 crores or 20 crores, so they are having 40 crore vehicles. Whereas even in our country, out of 100 people, only one is having a vehicle. So even if we are 134, the total amount of vehicles are not more than 10 crores or 15 crores. So we are not making much pollution. It is the advanced developed countries which are making more pollution than the developing countries. But the emphasis on the other way. We are not able to having a debate with them. Okay, just let us know how we are making more pollution than you. So you are having more number of vehicles. We are having lesser number of vehicles. So how can we produce more? So it's a different story altogether when we talk about this. So the best thing is, in case of this, is to having lesser number of vehicles, and that too, if we can turn to the this SI engines.
How many other technology reduce emission? Is there maybe another?
Technology means, I think I have already seen the plan. So alternate fuels are there, renewable fuels are there.
CNG.
Yes, alternate or renewable. I always talk about renewable because the fossil fuels are limited. So a fuel should be such which can be grown again and again, cultivated as per our choice. So something like our agriculture. So we cultivate wheat, rice, we fill in our valley. So water, again, it's a limited. In some cities, it is going off. Many of the world countries, they are going out of water also. Ethiopia, or Dochar, or Cambodia. Okay, so this is something that we can grow and then we can use. But again, there is a socio-economic effect on this. The land available to feed the human beings or the living beings will become lesser if we start growing the fuel needed to put into vehicles. So that is also a big question. People do not have maybe food to eat, but somebody is cultivating renewable fuel to fill in his engine. So that is also a big question, whether it can be done like that. Okay. Now, as I'm not touching into detail, but only thing, there is hierarchy of fuel. One, you have solid fuel like coal, another liquid fuels, petrol and diesel, another gaseous fuel. So now the gaseous fuel is the most cleaner fuel than liquid fuel. than solid fuel. So if we can move from liquid fuel to gaseous of any kind, whether it is LPG, CNG, HCNG, or a combination of all this, that is a much more cleaner fuel. And secondly, we are saving energy also. Because all the fuel, liquid fuels, are vaporized, first are atomized. And in atomization, you require energy. Your fuel injection pump, it consumes energy. And if the fuel is available in the gaseous form, there is no need to atomize. You have to simply, and I have done one more experiment on this, that you can run any of the engine simply by putting the LPG gas, which we usually have in fuel, just put that fuel into the air induction chamber, start the engine, put that into the air induction chamber, switch off the fuel supply, your engine will keep running. This is the first experiment which I did in 1997. Engine will not stop.
Without any calibration in the engine.
Without any calibration. But only thing is you will not get that performance, but it will not stop. Again, an analogy to this. Now, human beings, the God has provided two ways to eat. One is your mouth, another is your. What is the other way which you can eat? There are two ways by which you can supply food to yourself. One is your mouth. What is another? Anybody? Simple question. It is through your nose. भाई जब किसी का एक्सीडेंट हो जाता है इस माउथ बाउंड तो हाउ डू दे सप्लाई नोज के थ्रू दे देते. So similarly, in an engine there are two systems by which you can supply fuel. One is your fuel injection system, another your air induction chamber. The fuel can be supplied, वो भी तो वहीं जा रहा है. जहां से एयर ले रहा है वहीं से गैसियस फ्यूल डाल दो, खत्म. We have done MTech and PhD on this also. So this is similar. That is why I told you in the beginning, the entire analogy of human beings is being replicated into the engine. No component is different. You talk that component, I'll give you analogy in human beings. So there were some concerns and conflicts, I think, during that time. We already talked about कि all these additional equipment needed to comply with Bharat Stage requires money. So we are very happy that from April 2020 we will be getting. So some of the investment has already taken place. Thousands of crores have been invested in oil companies and thousands of crores have been invested by the engine manufacturing companies or auto companies. And similarly, thousands of crores will be taken from the consumer also in the form of higher initial cost of that vehicle or automobile. So every technology which is available is at a price. And nobody else is responsible. I would always say we ourselves are responsible. So we have made ourselves so dependent on these that I think today the number of vehicles are growing also exponentially. So again, I'll give you one personal experience which I have faced. I joined NIT Jalandhar in 1997 and it is almost 23 years. In 1997, there used to be 4 or 5 vehicles in our campus, which is spread across 154 acres. One vehicle was ambassador with our principal. Another was an ambassador with one of the faculty members. Incidentally, I also had one vehicle, Maruti, one bus, institute bus, that's all. And today, if I see there are more than 100 houses which has got more than 2 vehicles. One family having more vehicle than we used to have the entire campus. 4 भी हैं लोगों के पास. तो pollution कहाँ से कम हो जाएगी? So this is exponential growth of number of vehicles which are directly proportional to the emission pollutants. And before I, is it time available or we should conclude now? Hanji? 10-12 minutes. Na? So now I'll come to the concluding remarks. And I want your participation into this. Do you seriously feel that by upgradation we'll be able to combat or able to reduce the environment of pollution which we are talking? Okay, we are happy that we are switching over to Bharat Stage. तो क्या आपको अप्रैल 2020 in the month of May, June, July or the next winters दिल्ली में आएंगी या कहीं भी आएंगी जो लोग बहुत, क्या आपको फ्रेश एयर मिलनी शुरू हो जाएगी? So इतना फिर तामझाम करने का फायदा क्या हुआ? हाँ जी? Okay.
So it will cost an extent.
There are so many industries.
Actually, we are all students of science. The rate of growth of pollutants are not reducing. आप rate of growth नहीं समझ रहे. नहीं समझे आप? The rate at which we are producing and rate at which we are combating, they are mismatch. And because of it, the resultant would be an addition. There would not be any submission of these pollutants. Now, the only message I would like to give, and you should also give, is not to use the vehicles and come to our previous bicycles. These technologies are there for the businessmen, and in a way, indirectly, we are paying the huge taxes which we give to the government, to the developed nations in acquiring these technologies. These technologies have now come free to us. We have acquired these technologies. Our government has paid for this. But if we limit our aspiration, our ambitions to that extent, then I think. And second thing is to have a dedicated transport network for all the cities. Individually, if we depend upon, it cannot resolve. Collectively, at the government level, at a huge setup, then only it can be reduced. So thank you very much. So I am especially thankful to the management of NITTTR and Dr. Banwet and Dr. Dhami and Mr. Girdhar, who has given me this opportunity to interact and share my personal views along with the whatever is written in this chapter. So you can get or I can give you the PDF of this. This PDF is available to me, so I can copy it down, or you can take it down, so that you can reproduce this and to your syllabus. So just 5 minutes, we can take up the questions. Yes, and we can connect with the different centers also.
Centers feedback.
So first of all, let's have your queries.
Audience from the studio. Any question from the participant who are sitting here in the studio?
So you have mentioned that we are using DOC, DPM and SCR in DS6 technology.
Yes.
So apart from these three, we are using something else also.
No.
These three technologies.
Yeah.
Okay. Just ask questions from the different centers. Yeah, any question from the different centers?
Yeah,
If they wanted to raise any question?
He's raising hand.
No questions.
No question. Okay, in fact, thank you, Professor. Okay, that you have spared time for us and you have interacted with our participant in this course. We are very thankful to you that you have spared your valuable time for us. And in fact, now since we are coming to close to this program, I just wanted to get a feedback from you people. Have you given them the sheet?
नहीं सर वो रिलीविंग का देना है।
नहीं फीडबैक का वो दे दिया शीट लाइन
मेरी सीट पे ले गया सर सभी मैं ले गया तो
लेके आओ तब तक मैं इंटरेक्ट कर रहा हूँ
सॉरी मैं भी ले गया था
so I just wanted to know the feedback about this. See, there may be some content, there may be some expert who may not be good. Okay, you might have thought this should have been covered. Okay, so some sort of thing that we are interested in knowing that which are the areas where we need to improve upon. Okay, so anybody can. Yes, you. Nothing. Yeah. Yourself, any question? No feedback. See, I know. See, wherever I always give a feedback that this was good and this was bad. Okay. At least sometime we can say, no, sir, your food was not good. Okay. Because that is also the aspect. It doesn't mean that whatever I have taught, I am asking. Any about my institute, you can say, sir, the rooms were not good. Okay. Because all this feedback I had to share with my director. Okay. So that we try to improve upon that. You might have seen lot of work is going on in our hostel, in our guest house. In fact, I tell to many people that our guest house is very good compared to 3-star, 4-star facility. Okay, so that type of thing. Okay, but still we need some feedback from you people.
So your feedback can also motivate me also.
Yeah.
So
yes.
Sir, all the sessions were wonderful, but apart from them, from my side, PS Virdi sir and today speaker R.S. Bharat sir, they give a wonderful experience and the basic level to how to miss input in our mind is very wonderful. Just like a CRDI, we know the CRDI, but how actually compare with the normal system and explain. So I think all of us remember throughout the life what is the CRDI.
today I taught.
Good.
Thank you very much for your words of encouragement. So I can share in case sometime later I have a full maybe 1 or 2 hours lecture on understanding IC engine using human analogy. So that is also one of my favorite expert talks. So if we happen to have a chance, so surely I would like to talk about that, understanding IC engine using human analogy. कभी मौका मिलेगा तो I would like to share.
See, on the very first day, we had invited Dr. Khatri, B.S. Khatri from Delhi. And in fact, he was a visiting faculty to a good number of universities in Europe. Okay, and he is practically involved, real life problems he is involved. Many times he come to our institute and he asks, I need this type of person for my work. If you have specifically that type of person, you please let me know. So I remember around 3 years back, he was looking for one tech student in electronics. So he took that girl from electronics, and right now he says that she's still with them, working with them and doing R&D work. So he's collaborating with a lot of research work with IIT Delhi also there. And regarding Vidhi, you were saying that he was also a design engineer with Mahindra and Mahindra, with good number of reputed institutions. In fact, he was our student also. But at the same time, he was a design engineer. So he was working for a good number of institutions and industries. And now he's a freelancer doing his own research work, doing his own design work. Okay. So, and Prasad, it is his interest area, so we always feel pleasure in inviting him. Okay. So, I suppose just ask any feedback from the centers. No?
One center is disconnected because of power failure there.
Okay.
And one there has a center message in the box that their mic is not working.
Okay. आपके centers ऐसे ही हैं ना?
So anybody who is working in the area of alternate fuels? Nobody? Okay.
So I have some idea regarding ethanol and methanol.
No, that is not my question. I always say all those who work in the area of alternate fuels or renewable fuels, it is not that the number of publications, but if you are confident to apply the same fuel into your vehicle and run your vehicle, that would be the biggest PhD. So I have recently gone to some university, Chandigarh, they invited me for the PhD presentation, final viva. So I asked him, so you take your car, drive it 20 kilometers into this fuel, and your viva is complete. And he did not show any confidence in that. So we should do some work in which we are going. अब मैं डॉक्टर हूँ, दवाई बनाई फार्मा कंपनी ने, अपने बच्चों को नहीं दे रहा, तो वो क्या फायदा? So we should work in that area which is actually useful to the mankind. Just for the sake of acquiring a PhD or publication, we should not do that. So that is wastage of our resources, human as well as infrastructure.
So formally, I am ending the program here only. Okay. And I thank the participants at different centers also, participants sitting here, okay, for coming from such a long distances for attending the courses at our institute. So thank you. And I also thank Professor Bharat. Okay.
So
thank you.
So ये release certificate दे दो सर.
हाँ. सर्टिफिकेट ज्वाइन करेंगे